Hello, I'm Matt Morgan. In this lesson we're going to talk about balancing redox reactions, the ion-electron method in basic solution. This is from Wiley section 14-3. We will review the steps for the ion-electron method and we'll do an example in basic solution. So the last lesson we went over the rules for balancing redox reactions for acidic solution. For basic solution, you start exactly the same way. You go through all the steps and you do one more additional step to make the solution applicable for basic. So let's go over the steps for acidic one more time, then we'll show you what you need to do for basic. So the first thing we do is assign oxidation numbers. Then we'll split the reaction into half reactions. Balance all the atoms except hydrogen and oxygen. Balance oxygen by placing water. Balance hydrogen by placing H+. Place electrons to balance the charges. Then the half reaction should be balanced for mass and charge. Finally, recombine the half reactions. We'll multiply by a constant if necessary to allow the electrons to cancel. Remember, the whole reason for balancing redox reactions is to cancel electrons. So we're going to work an example and we're going to show how it will look in basic solution. There's our given reaction. We want to balance that. The first thing we do is balance it in acidic solution. In acidic solution, the balanced equation looks like that. Hey, I skipped a few steps, didn't I? But what I want to do in this video, just so it's not too long, is we're going to show what you need to do to convert this reaction to basic. Then later in the video, if you want to see how we got from the given reaction to the balanced, I'm going to go over that later. So remember, in basic solution we can have extra hydroxides, we can have extra waters, we can have extra hydroxide because it's an aqueous solution and it's basic. What we need to do now is get rid of those 4 H+ on the right hand side. A chemical equation is like a math equation. The arrow is like an equal sign. We can do whatever we want as long as we do the same thing to both sides. In this case, we want to get rid of that 4 H+. What we're going to do is add 4 OH- to both sides. We can have extra OH-, but we've got to get rid of the H+. There's our balanced solution in acidic. We're adding 4 OH- to both sides. On the right side, the 4 H+ that's already there and these 4 OH- that we add combine to make water, 4 H2O molecules. On the left side, the 4 OH just sits there because it's basic solution. So our final equation is, after adding 4 OH- to both sides, we've got the 4 OH-, the chromium hydroxide still there, the hypochlorite ion is there, the chromates are there, the chlorides are there. There was 1 water molecule on the right hand side. Adding to 4, we now have 5 water molecules. That is our balanced reaction in basic solution. You can look this over and see that it balances for both mass and charge. We've got the same number and types of atoms. We've got the same charge. Another note, the charge doesn't have to be 0. It just has to be the same on both sides. If you look at the Wiley reading, it adds the OH- to each half reaction before combining. You can do that if you want, but I like to balance it completely in acidic. That way I'm only adding OH- to both sides one time. It's up to you, whatever method works. That's the method you can use. So we balanced redox equations in basic solution. Practice these problems. There's no substitute for practice. And remember, Corey or I are available if you have questions. You can stop now if you want, but if you want to see how we went from the given reaction to it balanced and acidic, hang on. The rest of this video is going to go through those steps. Whether you watch this video or not, I recommend this is a good practice problem for balancing redox reactions. Here we go. First thing we do, assign oxidation numbers. Remember Wiley's section 14-1 showed us how to do that. We assign these oxidation numbers. I'm going to start with the chromium 3 hydroxide. We know oxygen has a -2 in this case. Hydrogen has a +1. The overall molecule is neutral. That means chromium has got to have a +3. In the next reactant, oxygen has a -2. Our overall charge in this hypochlorite ion is -1. So chlorine in this case has a +1 oxidation number. I know we said in the rules that halogens usually have a -1, but there are exceptions, and this is one of those. Going on to the chromate, oxygen has -2. There's 4 of those. The overall ion has a -2 charge, so in this case, chromium has a +6 oxidation number. Finally, the chloride is easy. -1 charge, -1 oxidation number. Looking at these oxidation numbers, we see that our half reactions are the chromium hydroxide to chromate and the hypochlorite to chloride. We're going to balance each half reaction, starting with this one. We see we've got chromium, same number on both sides, but we've got 3 oxygens on the left, 4 on the right. So we're going to have to add 1 water molecule to balance those oxygens. Next, we need to balance the hydrogens by adding H+. I've got 5 hydrogen atoms on the left-hand side, 2 for the water, 3 for the hydroxides. I'm going to have to add 5 H+ to the right. That gives us this reaction. Finally, we need to balance the charges. We need to add electrons. The left-hand side is neutral. The right-hand side has a -2 plus 5 has a +3 charge. So we're going to add 3 electrons to the right-hand side to balance charges on both sides. That gives us this equation. Here's some hints for balancing half reactions. You will usually add H+ to the opposite side of where you add water. You will usually add electrons to the same side where you added H+. So these are just some hints to help you as you go along. There might be exceptions somewhere along the line. I haven't found any yet. So let's balance the other half reaction. Hypochlorite goes to chloride. Same number of chlorines. Oxygens are not. So let's add 1 water molecule to the right-hand side. We now need to add 2 H+ to the left-hand side, giving us this reaction. Final step is we need to add electrons to balance charges. We've got a +1 on the left-hand side, the 2H pluses plus the -1 for the hypochlorite. We have a -1 on the right-hand side. So we need to add 2 electrons to the left side to balance charges. There is our balanced reaction. We've got an overall -1 charge on the left, -1 on the right. 1 chlorine on the left and right, 2 hydrogens on the left and right, 1 oxygen on the left and right. We are balanced. Finally, let's get ready to combine the half reactions. There's our balanced half reaction from before. Here's the one we just balanced. We've got electrons on the opposite side of the arrows, which is good, but we can't combine them just yet because the electrons will not cancel. We have to have the same number of electrons on both sides. We've got to multiply the top reaction by 2 to give us 6 electrons. We need to multiply the bottom reaction, this is going to be the whole thing, all reactants and products, by 3 to give us 6 electrons on the left hand side. That will allow our electrons to cancel. There's our top reaction multiplied by 2. Our bottom reaction multiplied by 3. Electrons will cancel, but look, something else will cancel as well. We're going to get some H plus canceling and some waters canceling as well. Let's see. Electrons cancel. That's good. We have 6H plus on the left hand side of the bottom reaction, 10 on the right. Well, 6 of those are going to cancel, leaving us with 4H plus. Also, the 2 waters on the left hand side of the top reaction will cancel with 2 of the waters on the right. Our final balanced reaction is going to be the 2 chromium hydroxides, the 3 hypochlorites, going to the 2 chromates, plus 4H pluses, plus 3 chlorides, plus finally 1 water molecule. That is our final balanced reaction. It took a while, but practice these. It's important that you know how to balance redox reaction. Now this is an acidic solution. We take this, apply the 4OH minus to both sides to make it in basic solution. It seems like a lot, but it will get easier with practice. Contact Corey or contact me if you have any questions. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.